Hey, what's going on, guys? The question is asking how much was required in terms of weight to push that object up. So they're saying it's bending motion up. It means we have to find the force in terms of weight. Whatever the force above that, that's gonna push this object up. So let's see how we can do this. So first of all, so we separate one part. So I take the top part first and draw a free body diagram. So let's say I use different color. Let's say so. Here we go. So we have this one right here, and let's put all the forces. So we know that weight is acting in the exactly vertical direction, so it's going to be W. And also we have a normal force that's going to be perpendicular to this object, so it's going to be, let's say, this is 90-degree perpendicular. So this is going to be my NA, and the angle that's going to make is exactly equal to the angle that's going to be making here. So that's going to be 8 degree. Then we can say there's a reaction force acting on it. So reaction force, let's put this way. Reaction force, this is R1, reaction 1, and I have to calculate this angle. Angle we can calculate simply by using coefficient of static friction. We have this one here, so we can use the theta. Let's say this is theta between the angle theta, so theta is going to be tan inverse 0.35. So if I calculate this one, this comes out to be 19.29 degree, and we are also going to have a reaction force in this direction. So let's say this is R2. This is also going to be theta, which is 19.29 degree. So now we can calculate R1 and R2 in terms of W by using sine law. So before to do that, I had to draw a triangle related to these three, W, R1 and R2. So if I draw that, I will get something like this. Like, let's draw. So this is it's a little bit messy. Let's redraw. Okay, so this is my triangle. Okay, this is my triangle that's making with R1 and R2. This is W perpendicular, W, and this is my R1, this is my R2. So we know the angle that R2 making with the perpendicular is, this theta is 19.29. So theta is 19.29. Therefore the total angle is going to be 19.29 plus 8 degree, which is going to be 27.29 degree. So that's making perpendicular to this, so that this is same as this one. So this is going to be equal to 27.29 degree. That's making perpendicular to this one, right? Then we can calculate this one, because this R1 is making theta 19.29 with this horizontal here 19.29. Then it means the angle that it's gonna make here is gonna be C shape. C shape means same angle. So this is gonna be theta. This is gonna be, this is making 90 degree, exactly perpendicular. So 90 plus 90 plus this one. So this is gonna be, the total angle is gonna be 90 plus 19.29 degree. which is equal to 109.29 degree. So that's this angle. From these two information I can calculate this angle. This is gonna be 100, and because total angle in the triangle is 180, so 180 minus 27.29 minus 109.29, which is equal to 43.42 degree. So from this information I can now calculate this R1 and R2 in terms of W. So let's do this. So first of all, if I take W, the angle opposite to it is 43.4, so W over sine 43.42 is equal to R1 over the angle opposite to R1 is here is 27.29 sine 27.29, and the angle opposite to R2 is 43.42. Actually the angle opposite to R2 is this one, 109, because yeah, 109. So sine 109.29. So from this one I can find the R1 in terms of W. So R1 is going to be W times sine 27.29 over sine 43.42, which is equal to 0.667 W. Then I can calculate R2 from this one, R2 from this equation. So this is going to be W times sine 43, no, sine 109, sine 109.29 over sine 43.42, which is equal to 1.373 W. So we have this information from the top diagram. So let's move to the bottom diagram. So to do the bottom diagram, I continue it separately right here. So I draw the bottom diagram, so it's going to be something like this, right? But we have to make sure the angle, like the whatever the forces we are putting, it's going to be exactly opposite to this one according to the Newton third law. So every action has equal and opposite reaction, so we have to follow this rule. So it's going to be NA acting perpendicular to this one. If the direction is this side in the top, the direction should be opposite right here. So this is going to be NA. Then we have R2. R2, this is going to be in this direction. Then the angle that's making with the horizontal is going to be, vertical is going to be 8 degree. This angle is theta. That's all, and we know this is a F is acting on it. That's the question. That's the question, and we also gonna have another reaction force that's gonna be R3. So that's gonna make angle theta. Theta is 19.29 degree. So this is gonna be the theta. This is gonna be also the theta. Now I can use the same method here, method I used here to find the F in terms of W. So to do that I have to form a triangle related to R2 and R3. So let's do that. So this is going to be F in this direction, and we are going to have R2 acting downside, R2 acting downside. Also we are having R3 acting in this direction. So from this information, so we can say this is going to be 90 minus this is theta, so this is, so if this is theta, this is going to be 90 minus theta with making with horizontal, so therefore this is going to be 90 minus theta. So 90 minus theta mean 90 minus 19 point 19.29 degree, which is equal to 70.71 degree. Then we have this one right here. So the total angle here is 27.29 degree. That's making with this horizontal. Therefore, this is going to make this horizontal. This is going to make 90 minus 29. So let's see, 90 minus 27.29. So from these two information, I can calculate the third angle. That's gonna be 180 minus 180 minus, this is equal to 62.71 degree. So 62.71 degree minus 70.71 degree, which is equal to 46.58 degree. So we have all three angles. Now it's easy to find the f in terms of w. So let's continue it here. We don't have enough space. Let's do this one here, and I use, maybe, yeah, I stick with the red one. So let's do this. F is gonna be f. So f here, the opposite angle is 46.58. So f over sine 46.58 degree. Then we are gonna have R2, the opposite direction, opposite degree is 70.71, so it's going to be R2 over sine 70.71 degree. Then we have R3, so this is our R3 over sine 62.71 degree. Now it's easy to solve everything in terms of R2. So if I put that, R3 is going to be R2 times sine 60, so R3 is going to be a sine 62.71 over R2, so R3 is going to be sine 62.71 over sine 70.71 degree, so which is equal to 0.942 R2. Now I can calculate f in terms of R2. So if I continue here, this is a separate part. So f is going to be equal to R2. So f is going to be equal to R2 times sine 46.58 sine 46.58 over sine 70.71, so which is equal to 0.770 R2. And so we have two different things in terms of R2. So from this one I can calculate F. So F comes out to be, so we have R3, right? So the relationship between R3 and R2. So let's see how we can do this. So relationship between F. So you can form the relationship. Since we don't have enough space, the final answer, if you like, you can create another equations with R3. It's going to be F is equal to R3 times 46.58 and multiply by R3, right? And if you do that, you will get F comes out to be 1.06 W. So this is the final answer. So this is how we find this F, and that's it. That's how we do this question. I hope you guys like this video. See you next time.